So, welcome to day 8. This is Alok and we are ready with the new topic of the day, one day, one video. So, today we are going to learn and understand about the logs, how RHEL 7 stores the logs. The objectives are see the basic architecture of logs in RHEL 7, the locations which are relevant for the logs, what are the locations where the logs are stored. How can you read the logs? We should be able to identify the differences between rsyslog D and general D. And then we will be learning how to change your date and time zone and NTP. So these are the objectives of the day. So first of all, let's understand what are logs. So logs normally are the files that contain messages. The messages might be about your system, kernel, services, and even the applications those are running on it. So there are different types of log files for storing various information. So you might find a different log file for system log, a different log file for security logs, and might be you'll find a different log files for cron job logs. So log files are very important for troubleshooting a particular problem and for also for checking out what is going on in my machine. So normally WhereLog is the location where the logs are kept persistently. So if I show you this, if I click here, I go to cd WhereLog. So this is the default location where the log files are stored. You can see there boot log, cron, dmessage, mail logs, and certain numbers are coming up here. I will explain you what these numbers are. So secure, this is the main directory. WhereLog is the main directory where you will find the logs. So some log files are managed by rsyslog service. So we actually have two services or which are used to manage the logs. So the standard log based the standard log protocol on the Linux machines is the syslog. So earlier it was the syslog protocol. Then they had a newer version of syslog. They call it syslog ng, next generation. And then now currently we have rsyslog. So let's do a small comparison between syslog, syslog ng, and rsyslog. So you might not find this particular comparison in your courseware. So all these, both syslog, not both, all three, syslog, syslog ng, and rsyslog, they all allows you to log the data from different types of systems. So syslog is the first protocol. That is the first protocol or the first project. It was started in 1980 and it's a very simple protocol that only supports UDP. That means even if the log is being sent to the remote server, it will not guarantee the delivery of the message. Then comes syslog ng. So syslog ng was introduced in 1998 and it has added some features over the syslog. Features like in syslog ng we have content based filtering, we have the facility that we can log directly to a database, and it uses TCP for the transport of the logs to the remote server. So that makes it more secure, and it also has the TLS encryption. Then now RHEL 7 uses rsyslog. So it actually uses two services, System D, General D, and R syslog. So currently I'm just talking about R syslog. So R syslog was introduced in 2004. It's again extended. It has extended the syslog NG with couple of new things like the introduction of RHEL protocol, RELP, Reliable Event Logging Protocol. So this is a very reliable protocol which is generally used by the industry where they can't afford a message loss, like the banking sector, like the financial sector. And it also supports rsyslog. I'm sorry, excuse me. So rsyslog also have something known as buffered operation support. So these are the three major protocols or the logging mechanism. So currently RHEL 7 uses rsyslog-D. So rsyslog is, as I had told you, is an improvement over the previous syslog-D. And what are the files which are managed by the rsyslog? You can find it. So the first thing that we have learned is that WhereLog is the main directory where you will be seeing your persistent logs. I will explain these. So a couple of very important are WhereLog secure, which will be containing your security logs, WhereLog messages, normal logs related to your services, mail logs for mails, boot logs can be found inside dmessage. I'll explain you this. Logs related to your cron jobs will be here inside the cron, and then you might find separate directories for separate application, like Samba logs you will be finding under WhereLog Samba. HTTP log you will be finding under WhereLog HTTPD. So if I go to Samba, you will have different log files. If I go to HTTPD, you will find different log file, access logs and error logs. So these are the logs. So this directory in itself is very important for you, WhereLog. And what are the files, the list of log files which are managed by the rsyslog? Currently we are talking about rsyslog. So what are the files? Those are managed by the rsyslog. You can find it inside a file there at crsyslog.com. So these are the files which are managed by log files which are managed by the rsyslog. WhereLog message, WhereLog secure, cron logs, pool logs, boot logs. So number one thing you should be knowing about this. So what does WhereLog message contain? If I share you WhereLog message, or I can do a less here. Sorry. First understand this. What log file contains? So WhereLog message normally contains the message related to your authentication, email processing, jobs. So purely debug kind of information will be available inside the WhereLog message. WhereLog secure will be storing your critical things, security and authentication related messages and errors. So if someone is trying to, I hope you will remember in the previous class I had shared this file while I was trying to do the SSH. So authentication related issues you can find under WhereLog secure. Mail related issues you will find under WhereLog mail log. Cron jobs related issues can be found under WhereLog cron. What are the cron jobs are started, stopped, those, and the boot issues, how the machine has booted, you will find under boot.log. So if I do a less here, you will find it. See here how the machine has started, mounted the sysroot, all the things right from the beginning of the machine when I had started the machine till all the services are up. You will find everything here. So there is a one more very interesting command which you can use to find out all the boot related activities. Is I have a very interesting command here that we know that system D is the your main job, or like the process PS3. I do a less here. So system D is the first process which I started. We had learned it in our process chapter, and the main job of the system D is to manage the boot process. So I have a very interesting command to find out how much time the system D has taken to boot the machine. So it might be like a point of you might be intrigued to know. There's a very simple command, system D hyphen analyze. It will show you how much time the machine has taken to boot. Means the time when I had started the machine and till I had the machine is properly up, on. So it has taken 32.312 seconds, in which kernel processes has taken this much of time, init rd has taken this much of time, and the user processes, those are in user space, have taken this much of time. So I can also use a very interesting option, blame, though I'm not blaming anyone. So it's an option here, blame. You can pass it on to find out the time taken by the individual services. See here. So this is the time taken by the individual services. How much time is taken by mount D? 960 milliseconds. How much time is taken by the HTTP service to start? 2.208 seconds. So this might be a very interesting thing. So in case you are trying to find out that which service is taking more time to boot, as it is being recorded there in the logs also, but these two commands can be very useful for you to get the boot time and to find that how much time each service is taking. One more thing before I proceed, that if you see here, you'll find here certain files having a timestamp, WhereLog message, and then the timestamp. What is this timestamp? So these numbers are the timestamps when the file was rotated. Look, it's very simple. The machine, your operating system, need to have a way to override the like old logs. Otherwise, the log file will keep on increasing. It will grow too large. So what happens? Your operating system automatically rotate the logs, say after 4 weeks. So once it will just keep the log for 4 weeks. Once the 4 weeks are over, it will automatically rotate the log of the oldest day. So this log rotation is being taken care by logrotate package. There's a package there, logrotate. This is the package which is responsible for rotating the logs, and the file which control is logrotate.conf. So see here, by default 1 week logs, weekly rotation will be there 4 weeks. So when the 4 weeks are over, it will remove the first week logs. You can change all these things. So in this way, if you see here, you'll find 1 week time, 20 and then 27, 7 days, 20 and 7, 27, sorry. So 7 days. For every week it is rotating the logs. Everywhere normally you will find the same 7 days of difference, and it will keep the log for 7 weeks, which is defined here. Rotate for 4 weeks. Keep 4 week back worth of backlogs. So you might see 4 old files, log files. Every week it's going to generate 4 log files. So logrotate.conf, and then it will check, and inside this folder also logrotate.d. So you might have a different log rotation like kind of priorities or specification for HTTPD. So if I see HTTPD, so HTTPD might have got different log rotation schedule. So that for every service, then you can configure it. Say for Samba. So by default, it will do the log rotation based on the configuration specified in logrotate.conf. Then it will go in this particular folder and will rotate specific service log as per the parameter specified here. So in this case, yum size is 30k, means I'm going to keep this log size file size can be of 30K. So you can specify sizes based on the application. So that you can do. So remember logrotate.conf, and then individual servers logs can be managed inside the directory @logrotate.d. That can be done. So important log files I had already shown you. Now this is a very simple thing, that these files will automatically keep on populating itself. One more thing, that all the log files, the rsyslog service uses the facility and the priority of the log message to find out how to handle them. So if I show you here rsyslog.conf, you'll find here, you can see there local 7 dot asterisk asterisk dot emergency cron dot asterisk mail dot asterisk asterisk dot info. What does that mean? So, and this is under the rules how it should be handled. So left hand side of the each line indicates the facility and the severity. Left hand side, that means this much, facility and the severity. The rsyslog file, like if you see somewhere, like in the line I have highlighted, they are using asterisk as a wildcard. So it can be used in the facility and the severity field. So that simply means that if I will try to explain you this line, so facility is anything, any facility, but the severity, info, mail, anything related to the information, mail, none, authpriv, cron jobs, normal log should be going on inside the WhereLog message. And if you see here, the facility is authpriv and the severity is asterisk now, anything. So it should be going under WhereLog secure. So your facilities or like the priorities can be, every priority has given some number, like 0 is for emergency. If I show you here cat, or I do a less here, less WhereLog message, just see this very carefully. If I see this, you will find that it's a system D process, severities. So this is rated, this is my machine, the timestamp, the facility which has started it or responsible for the log. So you will find everything there. Sorry, the WhereLog secure also. Let me show this. Okay, see here, these are all the authentication related issues. If you remember in the previous class also I had shared this file. So every syslog priority is given a number. 0 is for emergency, 1 is for alert, 2 is for critical, 3 is for error. So this I can see it here. See here, 7, local 7. These numbers are given. So 7 is the debug. So local 7. 7 means the debug facility. So error has got 3. I'd used asterisk here, any priority, anything. So every syslog priority has got a number. So, and you should be able to understand the rsyslog file very clearly. And then the logrotate also, and any point of time, again, we have been using this thing, any point of time you got a issue there, just write man rsyslog.conf and read about it. the priorities and everything. You will find a lot of information here, examples. Just go through it. And then we had also understood the log rotate. So if I check a entry and try to read what exactly is going on under WhereLog secure, so the first thing is the timestamp, as I have told you. Sorry, the first is the timestamp. Let me make it slightly smaller. Yeah, much better. First is the timestamp. Second is the machine on which has sent the log file. Third is the application or the process which has sent the log, and then comes the actual message. See here, timestamp, on which machine, which service is responsible, and what is the message. So this information is available in the log file. So you should be able to read the log files. Now, we had understood your RSyslog. Now let's understand general D. So in RHEL 7, log files can also be managed. Okay, one thing before I proceed further is that currently, being an admin, I have got different log files to see. For normal logs, I should be going on under WhereLog messages. Sorry, I should be seeing WhereLog messages. For authentication issues, I might be seeing WhereLog secure. So boot logs, I will be seeing WhereLog boot log. For mail logs, I have to go to different location. That might make your life slightly difficult, that I have multiple files to look for. Now in RHEL 7, log files are also managed by general D daemon. So general D daemon is actually a component of system D. So what general D does? So general D captures everything in a single place. That means general D captures your syslog messages, your kernel logs, your init RAM disks, your early boot messages, your standard output and error of all services. Everything are placed or captured in a single location. And apart from capturing it in a single location, general D indexes them and present to the admin in a much better way, so admin can search it faster. Why the search is faster? Because general D uses the native general file format that improves the searching and provide faster operations. And but there is a issue with the general D. So if I write here general CTL, see here, and I press enter here, I got everything. The boot log, see here, it's starting from the boot, it's initializing my kernel. The boot logs are coming up here. The boot logs are coming up here. All the boot logs, kernel is like getting initialized. My kernel getting initialized. It's the boot logs. Keep on scrolling, man. Right? Keep on doing. Then your file system is getting mounted. See here. You might now the services are getting started. So it's your WhereLog message. So any authentication issues also you will find it under the general D. So it, see here, it shows everything, like the cron also is coming up here. Cron, system D, kernel. So general D captures everything. But the only problem is that it's not persistent. They are not available after the reboot. Why they are not available after the reboot? Because they are not stored in some hard disk, or they don't use my hard disk space, like WhereLog uses my hard disk space. So general D messages, they are stored under a small kernel ring buffer. We call it a kernel ring buffer, and they are stored under run log general. So what actually happens, I'll just explain you what exactly is this kernel, this ring buffer is kernel ring buffer. Now, because they are in the memory, so I cannot use a lot of things. So the memory is limited. So it's actually good also that it's limited. But say, fine, I understood this by this ring that you are seeing here right on the screen. It's a limited memory in the ring. So only it will keep on using the space inside the ring. It cannot store something outside the ring. So that particular uh, area or the memory is limited. That's fine. But how can I find the size of the kernel ring? So I can give a very simple command here, though it's not related to your RSC stuff, but let's check it out. How much? So means general CTL. If I give general CTL, how much space will it take? How much messages can it store? How much space it has? So that is something controlled by the kernel ring buffer. So let's see how much the size is being allocated to the general CTL. So I can just simply give a command here. Actually, it's stored inside the kernel configuration files. So if I give this command kernel config log buffer, buffer shift, I need to give and the config file. So it's coming to be 20. Now I will use the Perl here. Just remember this command, need not to, because you're not doing Perl, but this command can be used to find out how much space the general CTL will take. I put it in KBs. And divided by 1024. So 256 KB. So that means the general CTL in my machine is taking 256 KB from the memory. Like the kernel that you have just seen, or I'll just show it to you again. This is the kernel. So that means the size of the ring is 256 KB. So general CTLs cannot store anything beyond 256 KB in my machine. It is configurable, but I'm not going onto that right now. So how can I see it? What are the things? How can I view the logs with the general CTL? So remember one thing, guys, the only benefit of the general CTL is that it gives you everything in a single space by the single command. Otherwise, you might need to go to WhereLog messages for normal logs, WhereLog secure for authentication logs, WhereLog mail log for mail logs. You don't want that. So you just give general CTL and press enter. That's it. It will use 256 KBs. I just shown it to you. You can also find the last couple of entries, say like we had used in the head and tail, say last 10 entries. I can use this. I can see only errors that, like suppose you are interested in only seeing the errors. So you can give the priority error. So only errors will be coming up here. So you can also might be interested in viewing the debug information. So write the debug. This is the debug information. You might be seeing only the critical errors. So critical. The time has been changed to the past. Alerts. Alert. Notice. You can find the notice also. Sorry. All in bold are the notices. Emergency. So these are your. I'm filtering the logs based on the priority. Emergency logs, whatever it is. So, and general CTL also gives me the control that what kind of output I want. Say if I give general CTL, fine, that is fine with me. I am presented with everything, all the logs at a single place. I am very happy. But if I use the output option verbose, so verbose will show me a much detailed output. See here. How much RAM has taken, everything. You might be interested in seeing an export option. It is very interesting one. So what export does, I'll show you. It actually convert the output into a binary, which might be very good for transferring it like over the LAN or the WAN. If you want to transfer it to a particular person, so you might be interested in using the export option. Then you might have you have a facility of converting it into the JSON format. So it's converted it into the JSON format. So you can get a more information about it by giving the more man of general CTL any point of time. So options. So see here, output, verbose, export, JSON format. So as I have told you, export is normally being used for network transfer. You can use that. You can also filter by time if you wish. If you give general CTL since the boot, last B, since the last boot. So if you are interested in seeing the kind of I can give a time also, say hyphen since today, as it will be storing for today only. You might be, as the main, one of the major benefit of the general CTL is that this indexing like the feature which I'm showing it to you right now. It gives you an amazing feature of indexing. Searching is very much faster. Say I'll give you one simple example. Say if I am interested in seeing the SSH issues, I give general CTL, then I can give this command underscore system unit is equal to SSHD service. So all the SSH related to issues will be coming up here. If I do a SSH to myself, let me show this. I'm doing it to myself. Fine, I've done this. I've done an exit here. I repeat the same command. So if it is like, you will be seeing the issues related to the SSH, your SSH service. So you can filter these things, but whatever the general CTL is presenting you, it's not at all permanent. It's not at all permanent. It will be lost after the reboot. So is there a way to make it persist? Is there a way to make it persistent? Yes. So as I told you, the general CTL by default stores everything under run log general. This is the location, current timestamp. But I can make it permanent. So this directory is volatile and the data cannot be saved. But in case you want to save it, you can save it under WhereLog generally. So let's do it. It's an exam like objective also. If you check the Red Hat website, just create a folder here, WhereLog general. Done it. Change the ownership of this folder as its root. If I give a ll-d of WhereLog general, change it to root, and the group should be systemd general, as that's the service that manages it. So I'll repeat it again. I change it. Now either do a reboot to see. So your changes will be saved here. I'm doing a reboot here. The best way is to do a reboot, or you can kill the process and start it again. So you need to give the service systemctl restart systemd-general. Let's start it. Let's get it started, and then I'll show it to you. So important log files, locations, importance of logrotate, logrotate.conf file. You should be having a very clear understanding of where exactly the general D stores the logs under run log general, and you should be knowing the Linux kernel ring buffer size, where it is actually like storing, and what is the capacity of the ring now. So that I had shown it to you. So I had done it. So if I show it to you, it will be storing it persistently inside that folder. Just a moment, guys. Let me just adjust it for the video much better. Okay, I go to SU hyphen Red Hat. If I go to WhereLog general, you will find the timestamp, the time when I have rebooted the machine. So this is your general. So here it stores. So in this manner you can make it permanent. So now some of the very small commands which are a part of our day objective. How can I change the date and time? So you have a very interesting command, time date ctl. It shows you your current time, your time zone and everything. You can get a list of all the time zones available by just giving the command list time zones. These are the current time zones. So in case I want to change my time zone to any other place, I go to El Salvador. So I copy this. I can change my time zone, time date ctl set time zone. So if I give it now, you'll see it is IST, Asia Kolkata. So I can change it, time date ctl set time zone and the name change. So see, even the time has changed suddenly. So if I give it time date ctl, it's changed. So I can go back to my time zone. I can see here you will find Asia Kolkata here. Here it is. The machine reacts very fast. See the current time, it has changes 6:39 morning. So if I give it once again and change it to Asia Kolkata, it again changes to the current time 1809. So you can use that time date ctl to change your time zone. You can also use it to set the time. So I'm just show it to you. Give time date ctl set time and whatever time you wish to give, like this. So I'm not pressing enter here, I'm just doing a control C here, but you can use this. Then you can also configure your machine to get the time from the NTP, network time protocol. So you must be seeing here, currently my machine is not taking the time from the NTP, which it will not take because I'm not connected with the internet right now. But in case you have a NTP server and you want to connect it to the time, so you can just give here set NTP true. That's all. So if I show you here, it's true. So where is the IP address? Where is the IP address of the time my NTP server? So the time in the NTP is being in RHEL 7 is being managed by the cronny D service. So it's stored under hccronny.com. So here these are the default values. If you have your NTP server say 10.11.12.13, just specify your address here. Yes, obviously make sure that you should be connected with the internet, that this particular IP should be reachable. Comment them out and you can restart your cronny. And remember one thing, guys, whenever you are trying to get the IP address of an NTP server, try to find out the NTP server with a say kind of a lower stratum value. So stratum 0 is actually the real NTP clocks. As you can see here, these are your atomic clocks and the radio clocks, which I cannot access straight away. So then stratum 1 is those servers which are directly connected to the atomic clock and the radio clocks. Then stratum 2 are the machines and 3 are the machines which are connected over the network. So it's much better for you if you will be receiving the time from a stratum 2 server rather than from a stratum 8 server, because stratum 2 servers, as you can see here in the picture, they are much more reliable as compared to the stratum 8 and stratum 9 servers. So try to get as close to the straight on one servers while syncing the time. So once you had done it, it's very simple stuff. Just try to restart your cronid, and if I show you here, though I will be getting an error as I'm not connected to the internet, I can give this command sources-v to find out which IP address my machine is taking. So my machine is taking, trying to get it from 10.11.12.14, the IP that I had given. So this is an exam objective also. If you check the Red Hat website, how to configure your machine as the NTP client. So this all you have to do, and making your logs persist, your general CTL logs persistent, permanent, is also a very important examination objective. So take care of those things and understand these basic things about the logs, the kernel size. Getting the size of that Linux kernel ring buffer is very interesting, because normally you will not find those two commands in your book, that what actually is the size that is being used by the general CTL. So this is all for the day. So what's in the next class? In the next class, we will be learning how to change the IP addresses, how to assign the IP address, simple commands like assigning the IPs. We will be learning about NMCLIs, very interesting and is very important, like from the examination perspective also. We'll be learning the NMCLI, assigning the IPs, then SCP and rsync commands, very small stuff, and then the yum. So I hope we'll be able to finish our first module either in the next class or in 2 more days. Thank you very much. See you again tomorrow. Bye bye. Take care.